Yeah. Now
Now we can hear you.
it's okay.
Now
Yeah.
we can hear you.
Okay. Thanks, Professor Yan, and thanks, Eric, to host this section. I'm very glad to join this discussion. So I'm Joe from Chongqing University. My background is also like Xue Rong in computer science and automation. Today, my topic is about from the energy issues, energy respect. How do we think about the artificial intelligence? Let's move on. Okay. Like a general background about the relations about AI and energy, I will take two examples to illustrate this, such relations. One is energy prediction, another is building energy efficient retrofit. First, Eric and also the Melanie also talk much about the AI and the AR in energy. Now I'm want to sharing my thinking about the difference between the AI, artificial intelligence, and the AI application in energy. Now, the artificial intelligence always like terms in computer science to make machines emulate thinking like human and animals, like this evolutionary of human intelligence. We wish the artificial intelligence also grows from weak one to the stronger one. However, we also find the difference that the computer scientists also only focus on learning theory and the algorithm. They studies the distribution estimation, clustering, classification, regression, and so on. But like us, we are energy engineers. We mainly focus on the implementation and task completeness, like energy prediction, optimal scheduling, real-time control, measurement and verification, etc. I want to emphasize that there's a big gap between the computer science and the energy engineering. The gap is that normally the computer scientists feel that they developed well advanced AI algorithms, but they find them useless in practical applications. For energy engineers, they also feel the difficulties. They can't change a suitable AI algorithms for a specific task, and they don't know how to revise it when the original algorithm performs bad or even incapable. Now I want to show this picture about the, the main reason may be that the AI algorithm in computer science mainly studies the evolutionary of general human intelligence. But for us, we want to study the energy exploration intelligence. Normally, the energy exploration intelligence is more complicated and more recently than the general human intelligence. For example, we have a long history of energy exploration from the raw energy exploration like the horse, wind and the fire. Then we go to the coal and steam and then move to the electricity. Then we nowadays we take use of renewables. Now we want to move on to the next step, the smart energy system and grid. Oh, this is the I call it the energy exploration intelligence. This must be very complicated than like the humans from the ape to the real modern human. Okay, then I also generalize some reasons of this gap between the computer scientists and the electrical engineering. The most challenges in energy engineers is that we face long formulated data, such as pressure, the temperature, and so on. They shows heterogeneous with different sources. We face multiple tasks normally we don't focus on one, say energy prediction. We want to use prediction to optimization and scheduling. So we almost always wish to complete multiple tasks. The third one is that our challenge is we also take use of data, and also we have to rely on models, physical models. So this is a hybrid of model-based and data-driven based. The fourth challenge is that multi-objectives. Okay, in energy engineers, we also want to balance economic, feasibility, and accuracy, but now we come back to the computer scientists. When the computer scientists study the AI, they only use the formatted data, image, text, speech. Okay, they are homogeneous characters. Okay, they also focus on single tasks such as classification, prediction. They are mainly data-driven. It came from the camera, came from the voice, and so on. The objectives are also single. Accuracy, we want to improve the such as classification accuracy and so on. And now, finally, the biggest problem now we think the AI in energy engineering is that now we mainly use solution-based thinking, such as that picture shows. When we take use of the wind, we in the Asian area we use the wood tools. Then when we want to take use of the steam coal, we use the steam engine, and so on. We use generators. Now move to the PV and the turbines to take use the solar energy and the wind energy. Now, the next step is how we fulfill the smart grid. Now, with the same things, we separately think in this problem. We want to rely on the AI. Now, does the AI is the solution of the future smart grid? That's a big question. Also, that's a panel discussion that maybe the reason of this discussion. But move back when we come to the AI, how we think about AI. The computer scientists, we think it as evolutionary based thinking mode. They integrated the brain development from the apples to human, modern human, how the brain's development, the mechanisms. Then we generalize the rules, we generalize the rationale behind such a development. We model them, and then we propose some new AI, such deep learning. I call it evolutionary based mode. So I think that's why the AI has a large a step of improvement as we think it integratedly. But now, when we think about smart grid, we think it separately. That's a problem I think I mentioned here. Okay, so now I then give two suggestions on bridging such gaps. The first one is from the computer scientists. They have to think about how to broad AI research with respect to different data formats, different tasks, and other challenging issues mentioned before. From the side of energy engineers, we have to think about the energy issues from the solution-based mode to evolutionary-based mode. Here I show two pictures to illustrate my my comment here. Yeah, in current the solution-based mode, the AI is just a solution of smart energy and smart grid, and then we want to rely on AI to fulfill the resulted smart energy. This is a solution-based mode, but if we change our mode to the evolutionary-based mode, we can consider how the evolutionary of human intelligence, how evolutionary of energy exploration, and also the tools technology improvement factor. All these factors we consider them together, then we want to take use of energy exploration and intelligence to develop the next generation of energy and its associated solution. Maybe AI, maybe the other technologies such as IoT that beyond of AI. Though the I want to say that the intelligent energy and AI, also the AI has a very short history for about half a century, but energy exploration intelligence exists very long history, more than thousands of years. So that's the different patterns, modes to think about the how to fulfill the smart energy. Okay, then I want to show two examples that show our thinkings, how we think the energy issues in the evolutionary mode. Okay, the first task is energy prediction. We all know that we have to predict the energy, also including the demand and also renewable, because we want to keep the power balance. We want to we want to for the economic dispatching, even for the location and the sizing of new installation of the generations. In a large time scales, the energy prediction can influence energy policy. There are three main categories of the energy prediction task. The short-term prediction, that's mainly for the task of power balance and economic dispatching. The medium-term prediction is maybe in a week scale. We want to predict the energy in a week or in a month. Then this result is can be useful in the location and the sizing of new installation. In the long-term scales, we want to predict the energy in a year or in a half year. Then this long-term, then we look back the last 10 years and the future 10 years, we can revise the energy policy. So that's why we have to, we have the so much challenges of energy prediction. Normally, how we solve this energy prediction task, we normally regarded the energy profiles as a time series. Then we use the time series prediction method like linear regression, support vector regression, neural networks, such as backpropagation, recurrent neural network, deep neural network. In most energy prediction methods, that means that any time series prediction method can be used if we regard the energy profile as a time series. And that for different kind of energy production, we have to choose one model or one method. For short term, we choose one method, but for the medium term and long term, this method never works well. So we have to choose another one due to this time scales, the different time scales. Okay, so the question is that, is one prediction model sufficient for completing all these tasks? Okay, we want to think about this one. We don't want to solve this different short-term, medium-term, and long-term prediction with three models. We want to solve this three tasks with one model. Is that possible? Okay, so then when we look back, we learn from some ancient weather forecast experience. Okay, in ancient, when we plan the work of tomorrow and the work of weekly plannings, the ancient people, okay, they also look at the skies, the light sky image. They can achieve the short term, such as the weather of tomorrow, and also they can also predict the weather of future week or future months. Then, based on this hybrid prediction, they can do decision making of short-term and medium-term decisions. Okay, then how we can learn from this our agents? Okay, they do the multiple task prediction by human intelligence, and also the short and medium-term tasks are correlated. If we think that for the next few weeks the weather is raining, okay, tomorrow the possibility of raining is very large. So this is just a simple example to show the correlations. Then based on the multiple task prediction, they can do the comprehensive decision makings. Then we evaluate the AI algorithms in energy prediction. The AI algorithm can complete one task, but which AI algorithm can emulate such energy exploration intelligence to complete all these tasks simultaneously? Then we take the example we called the neural network called echo state network. It's a kind of a recurrent neural network. It consists of input layer, hidden layer, and output layer. The hidden layer called reservoir. It's a famous algorithm proposed in science in 2004. Now we can use it for any chaos time series prediction. It must be competent in only a prediction task, such as say the short-term prediction. Then the weights in hidden nature and the input nature and random, and they will have to learn the weights of output nature. Okay, this may be the only mathematics in this talk. Okay, we neglect all this mechanism here. Just say it can be used for only one prediction task, but we also revise. Our work is that to revise it for multiple task prediction. We call it a multiple time scale echo state neural network. This for this neural network, the input is hourly solar irradiance, daily solar irradiance, weekly solar irradiance, or monthly solar irradiance. Output is that we use different hidden layers, and then we integrated them together and predict the future hourly irradiance, weekly irradiance, and daily solar irradiance. We combine it together. It seems like that different from the original ESN, we normally parallelized the different hidden layers. Each hidden layer is capable to handle different kinds of energy profiles in each time scale. Then we can use this revised algorithm. We can do the hourly solar prediction and the daily solar prediction well. Okay, the algorithm can be found in our recently published paper. The findings is that the multiple tasks can be completed simultaneously. Also, the accuracy of each prediction task can be improved after considering the correlations. Here is the comparison results between the original algorithm and our proposed algorithm. We found that the accuracy of and computational efficiency has been largely significantly improved compared with the original one.
May I just ask you, do you think you can try to start closing the presentation?
Okay. That's the second one is we call the building energy efficiency retrofitting. Okay, due to the time limit, I will end it soon. Yes. Okay, then normally we just regard it as an optimization problem. Then any AI, the intelligent optimization algorithm, can be used to solve this problem to find the best retrofit solution to improve the energy efficiency of the buildings regarding the comfort, energy saving, emission safety, and so on. This problem is challenging due to the included three dimensions such as the time dimension, the building dimension, and the technology dimension. Then the two questions arise in the real application. First is how to deal with the decay. If we regard no decay, then the AI algorithm can be used directly. Then we regard decay, we have to consider the maintenance, the control action. Okay, so we studied the different control methods. We compared it. The feedback control and the adaptive control can both work well on this energy efficiency retrofitting issue. The second question is about how to deal with uncertainty, because when we regarding the state the decay of the buildings, they come from the good to average to bad and failed. This also uncertainty transitions. Then we have to consider the use of predictive model, predictive control to handle this. Then we use different kind of model predictive control strategies. We found that when we consider energy, we can find one solution, but when we can focus on economic, we can find a totally different solutions. Okay, let's move to the final part. Sorry for the outuse of the time. So now we're thinking about AI in energy industries. We have to mention that there's a different kind of challenges in this energy application. Normally, these models are dynamic model, multi-objective model, and incentive model, and chronic sourcing model, rather than static model, single object model, and non-sensitive model, single state model. When we thinking about the different kind of model, we have to consider the optimization, control, the game theory, or different kind of we call energy informatics and intelligence. Okay, there's some reference provided for future details. We have to thank some of our partners and courses for this talk. Thank you.